So let's see an example of how to find velocity and acceleration in angular terms when I'm given an angular position. So here I have an equation for the angular position as a function of time. We can see angle as a function of time is equal to 20 times t squared minus t cubed to the fourth. Now if I want to find the angular velocity, I know that angular velocity is equal to the derivative of the angular position. So this is going to be d phi dt. So I have to take the derivative of this with respect to time. And I can do that. The derivative of this with respect to time is going to be 20 times 2t minus 3t squared over 4. So now I have an equation for my angular velocity. Now, if I want to find the angular acceleration, I can do that as well by taking the derivative of the angular velocity. So I take the derivative of my previous equation, and I can find an equation for the angular acceleration. So that's going to be 20 times, our derivative here is going to be 2 plus 6 times t divided by 4. Okay, so very quick to use calculus to take derivatives to find expressions for finding the angular position, angular velocity, and angular acceleration for any time that I'm interested in, any time t. So now let's say that I want to know what is the angular position, angular velocity, and angular acceleration at a time t equal to 0. So all I would need to do is plug in a 0 anywhere that I see a t. So my angular position at time 0 is going to be 20 times 0 squared, I'm plugging in 0 anywhere I see a t, minus 0 cubed over 4. So my angular position at time 0 is going to be 0. Correspondingly, if I wanted to know angular position at time equal to 1, everywhere that I see one of these t's, instead of plugging in 0, I would plug in a 1. So I can find, let's say, the angular velocity at 1 second. I would just plug in a 1 anywhere I see a t. So I'd have 20 times 2 times plug in a 1 for this t minus 3 times 1 squared over 4. And I would have my value. I would have my equation for solving. I would get 20 times 2 minus 3/4. And you plug this into your calculator and you get your final answer that omega is equal to 25. Now what I want to do is also use correct units. And the units for angular velocity are going to be, by definition in the SI system, radians per second. And then let's say I want the acceleration. Let's change the time I'm going to get the acceleration. Let's do acceleration at a time equal to 2 seconds. So again, I just plug in my time for t. So I get 20 times 2 plus 6 times 2, where I plugged in my 2 for this t right here, all divided by 4. So I got 20 times 2 plus 6 times 2 is 12 over 4. So I have 20 times 2 plus 3, so 20 times 5. So it's going to give me an angular acceleration of 100 at a time of t equal to 2 seconds. So that's how we can find angular position, angular velocity, and angular acceleration. We can find general expressions by using differential calculus. And then we can find those actual values at any time by just plugging in for the times anywhere you have t's.